Hello, we're going to work on solving systems of equation by substitution today. The thing with substitution means that we're going to take one of our values, like our z value here, and we're just going to substitute it in to another equation, and we're going to solve. So we know that z is equal to 3, so I'm going to rewrite my equation as 4x plus 4, and we know that z is equal to 3. And that equals 4. And we're going to solve all the way down for x. So we know that 4x plus 12 is equal to 4. And 4x is equal to negative 8. So x equals negative 2. So we substituted z in for our value. And now we're going to substitute our value for x and z into our first equation, and we're going to solve for y. We want to be careful because our x value in our first equation up here has a negative, and the x that we solve for also has a negative. So it's going to be negative 2 minus 5 times y minus 5 times 3, and that's equal to 2. And so now we have an equation in one variable, y, and we're just going to work our way through. We're going to simplify, combine like terms, and solve for z. So I'm just going to work through. We have negative 2. That becomes positive 2. Minus 5y. Negative 5 times 3 is negative 15, and that all equals 2. So I can combine some like terms here. 2 minus 15 would be negative 13. So this simplifies to negative 5y minus 13 equals 2. And I'm going to add 13 to both sides. And we get negative 5y is equal to 15. Divide everything by negative 5. And y equals negative 3. So the solution to our system would be all 3 coordinate points. We have to write it as an ordered triple. We would write it as negative 2, negative 3, and 3. And so that's our x, our y, and our z. All right, moving right along. The next substitution problem is not quite as easy. It's not quite as nice. So we were going to have to do a little bit of additional work here. And we have an equation in 3 variables, an equation in 2 variables, and we have an equation in 2 variables. So we need to take our 2 equations. Let's call this equation 1, equation 2, and equation 3. So we need to take equation 2 and equation 3, and we need to solve them for a variable. And so looking at equation 2, it looks like it's pretty easy to solve for y, so that's what I'm going to do. I'm going to subtract 4x from both sides. And we are left with y equals negative 4x plus 7. And so this is good. So I can substitute eventually. We know y is equal to negative 4x plus 7, and we can substitute that in. Looking at equation 3 over here, I'm going to solve for z. And so, excuse me, yeah, let's solve for z. You could solve for x, but I think z might be a little bit easier. So that means I'm going to subtract 2x from both sides. And so we get z is equal to negative 2x plus 3. And so we know what z is equal to. Now what we have to do is we're going to take the values or the equations that we solved, and we're going to substitute our values. We're going to substitute our y value in here, and we're going to substitute our z value in here. So let's just do that. So taking equation 1, we have x plus, and we're substituting in this y value. So we're substituting in negative 4x plus 7. Let's make that a little bit nicer. And then we're going to substitute in our z value. So that's going to be z is negative 2x plus 3, and that's equal to 5. And so what that allowed us to do with this substitution, and this is kind of what we were trying to get to, is we have an equation that only has one variable. And so we know how to solve that. Now, you didn't need to put the parentheses on here if you didn't want to. It's not necessary, but it's helpful to get in the habit in case you have a coefficient that you have to distribute. And fortunately, we didn't have to do that here. So I'm just going to rewrite it without our parentheses, and we're going to start kind of cleaning this stuff up. So we have x minus 4x plus 7, and it's minus 2x plus 3 is equal to 5. We can combine some like terms here. Let's see. So we've got an x minus 4x. So that would be minus 3x. And then minus 3x minus 2 more x's would be minus 5x. And for our constants, we have 7 plus 3 is 10. And that equals 5. And so we're solving for x. So I'm going to subtract 10 from both sides. Just keep working our way through. And we have negative 5x equals negative 5. We're going to divide everything by negative 5. And we get x equals positive 1. And so at that point, we've done a little bit of work. And we have one variable solved. And so what we're going to do is we're going to use that, and we're going to plug in to our second and third equation. We know what x is, and so we're going to plug that in for x, and we're going to plug that in for the other x, and solve for y and z. I'm just going to recopy my two equations down here, so we've got them a little bit easier here to see. And so here we go. We know that equation 2, we wrote that as negative 4x plus 7. We said y is equal to negative 4x plus 7. Plugging that in for x, and we get y equals negative 4 times 1 plus 7. Cleaning this up a little bit, what we end up with is y is equal to 3. We're going to bring equation 3 down, and equation 3 was z is equal to negative 2x plus 3. And so we're going to substitute again. We're substituting our x value in because we solved for x and work our way through. So we get z as negative 2 times 1 plus 3. And so z is equal to 1. Write it as an ordered pair. And so our solution would be in x, y, z, it would be 1, 3, 1. And those are our solutions.